Okay, I need to... All right, 7.3, Compound Inequalities in Interval Notation, College Intermediate Algebra, page number 408. All right, so given that inequality, again, we solve this the same way you do any other equality. And again, I put 2x plus 3 there for reasons that I have no idea. Okay, so there's our equation. All right, so we solve it the same way we do an equality. So what do we do to solve this? Okay, plus 1 here and plus 1 here. And that gives me 3x plus 4 is less than 2x. Now what? Which gives me 4 is less than negative x. Is that very pretty? No, it's not. Okay, I can divide both sides by negative 1, switch the sign around, and change everything. Is there an easier way to do this than the way that we have written up there?
I don't know if it's easier, but I would have done negative. I would have minus the 4 and put it onto the right side, and then minus the 2x and put it onto the left side.
Okay.
But I don't know if that's any really different.
So, you would have done 3x is less than 2x minus 4. Subtract 3 from both sides.
Yeah.
Okay. And then I can subtract 2x from both sides. Why would you do that rather than the other way? You're not fighting with negatives. You don't have the negative x. You're not having to switch the signs around. You end up finding out that really it's just an easier way. Neither one is wrong. You get the same answer. It's just the other way there's more of a chance to make mistakes than this way. Okay, do you remember the fact that when you divide by a negative, you have to switch the sign? So if I were to have, if I had a problem like negative 2x is less than 4, if I divide by negative 2 and divide by negative 2, in order to get rid of that, I have to switch the sign around. Okay, and it's only, and this is really important to remember, it's only when you divide by a negative. When you add or subtract, like here we subtracted 3 here from both sides, the sign did not change. We did not move anything. It only happens when you divide by a negative, because what you're doing is you're taking the other side of the equation, in this case, this side, which used to be a positive number, and now you're making it a negative. So now you're making it smaller. Well, that's why your sign has to change, because the sign has to point toward the smaller number. So when you made it negative, you automatically made it smaller than the other side, because what happened to this side? It became positive. So you had to switch the sign because you made this positive and this negative. Well, a positive is not smaller than a negative. It's bigger, so you had to switch the sign. So regardless of whether you understand why you switch the sign, you don't really have to understand why. Just make sure that when you divide both sides by negative, the sign changes. It drags along with it. Okay, so we've got this problem right here. X is less than negative 4. So there is a method or a way to write x is less than negative 4. And this way of doing it is called inequality notation. And that's what we're going to do right now, is show you what this, or set builder notation, I'm sorry. So we've got what is called set builder notation. And it's set builder notation. And maybe you've seen this before. I don't know if we've done it yet. But you make a set sign set builder notation, you put an X, you put a vertical line, and that vertical line stands for the phrase such that. Such that X is less than negative 4. And that's called set builder notation. So what that says is the set of X such that X is less than negative 4. How many numbers are less than negative 4? A lot. How many is a lot? Infinite. How much is infinite?
Incomprehensible.
Right, it makes your head explode. Okay? So that is set builder notation. Not only do I expect you to be able to write that correctly, I also expect you to be able to verbalize that. The set of all X such that X is less than negative 4. So the key part of this is the set of all X such that. That's always going to be the same. Set of all X such that, and then you read what carries on there. Okay. Okay, so that's the way you write that. If you were to graph this, you would graph this like negative 4, and this is less than negative 4. So what you have learned at this point for X is less than negative 4 is you've learned to make an open circle to show that you're not including negative 4 in your answer, right? Is this stuff that you remember? Okay, so let's do this in red. Open circle, and then a line going into infinity in the negative 4 direction. Ooh, that's pretty cool. Okay, that's one way that you've learned to graph. Don't forget that way to graph. But as you get further and further into math, you learn other ways that they graph, and it's simply because it makes the understanding, it makes symbolism a lot easier. All right, another way they graph, instead of that open circle, they will use a curve and draw this line this way. Okay? In that curve, it's kind of like one side of a parenthesis. That curve means that it does not include negative 4, just like the open circle does. Okay, let me show you what it looks like if we were to include negative 4. So if X is less than or equal to negative 4, we'd still have our negative 4 here. And what do you do in the way that you've learned how to do it? You make a closed circle, right? So you close the circle and draw the line. Okay, so that's the old way, which again you'll still use. But the new way is, instead of a parenthesis like this up here, we're going to make a box. Kind of a squared off. That means that we are including negative 4 with our answer. See, we have our greater or our less than or equal to sign. So the box means that we're including, the parenthesis means that we're not including. That's the only thing, that's all those two symbols represent. Okay, so in fact, let's go back. So this other method, this is called interval notation. Interval notation. All right, so let me get rid of some of this stuff so that we're not looking at everything that we have here. So let's just get rid of all that. All right, interval notation. We had X is less than or equal to negative 4. Or we had just x is less than negative 4, didn't we? Okay. Interval notation. What does the curve on the parenthesis mean that I have here? It doesn't include negative 4, right? So we put a negative 4 there. How far to the left does this go? Infinity, right? You guys ever work with negative infinity?
No.
Have you ever heard of negative infinity? Okay, positive infinity on your number line is this direction. Negative infinity is just this direction. That's the only difference. So if we're at negative 4, if we want to include all the numbers that this answer right here can include, we start at negative 4 and we make a curve to show that we're not going to start at negative, we're not going to include negative 4. And then we show negative infinity with a curve on it, because do we ever get to infinity? No, so it can never include infinity. Whenever you write an infinity sign and you're trying to decide, do I make it to this sign or do I make it to this sign? It's always the curvy one, because you never get there. If I use the box here, right here, that means I get there. Okay, so that's just the standard way of doing that. I'm giving you a lot of stuff that you've never seen before. Is this complicated, or is it just a lot of stuff? Just a lot of stuff. Okay, so if I were to show x is less than or equal to negative 4, the difference between what I have here and what I would have for this one would be a curve with negative infinity, because it still goes negative infinity. My negative 4 would be here, but this would be a box showing me that this time I'm going to include negative 4 as one of my answers. Okay? So it's going to look a little bit different. So the only difference between this up here and this down here is this one down here includes negative 4 and this one doesn't. That's the only difference between those two. Sometimes you're going to get an answer like, let's see if I can get rid of a bunch of this stuff. I wonder how it decides what it's going to let me erase.
Probably when you pick up the pen between a certain amount of time.
Yeah, that's probably it, because it's weird how it just kind of randomly seems to pick. I need to figure that out so I can stay on top of it. Let's say that our answer is negative 3 is less than x, which is less than or equal to 4. All right, so what are my possible solutions here? If I were to draw a number line, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so at negative 3, would I draw an open circle or a closed circle at negative 3? Open. Would I draw a box or a curved parenthesis? A curved parenthesis. Okay, so let's do that, because it does not include negative 3 in our answer. Okay, let's look at the 4. A box or a parenthesis? Box. And our x value can be any number between here, right? So you never have to question what you're going to shade, because you're always going to shade between, obviously between these. This is curving and this is curving this way. You know you're not going to have anything out here because everything's pointing to inside of here, right? If I would have had an open and a closed circle, then you're kind of confused. Is it to the left of the open circle or to the right of the open circle? Whereas this way, it makes it real easy. It's within the curve or the box. So that makes it a little bit easier. So that's how you would graph that. If you were to write this in interval notation, you would do it this way. The curve and the box, which represents these two, you're going to put a negative 3 on that side of the curve and a 4 on that side. And you've just shown me, using just two numbers and two symbols, what my x values can be. They can be any number between -3 and 4, not including -3, but including 4. And right there, you know how before you would say x equals 3 or 2, or right now you've got these symbols that you can show all of the possible answers that you can have for this equation, or this inequality right there. So hopefully that will make it a little bit easier. All right, so let's jump to where did it go? Example number 2, -2y minus 3 is less than or equal to 7. And what it's asking me to do is find the solution set, meaning that I'm probably going to have more answers than one, especially with an inequality. I'm probably going to have an infinite number of answers. Okay, in this equation, I have one inequality symbol, so I'm probably going to have an infinite number of answers. If I have more than one inequality symbol, I have a smaller area that I'm looking at. It doesn't go into infinity necessarily. Okay, so I'm going to solve this just like I normally do with any algebra problem. I'm going to add 3 to both sides. I'm going to add 3 here. I'm going to add 3 here. So this goes away, less than or equal to 10. Divide by -2. Divide by -2. Y is greater than or equal to -5. So again, because of that -2, I had to flip the inequality sign around. And there's my answer. Y is greater than or equal to -5. And if I were to, it depends on what they're asking me to do, if I were to graph this, I would have my graph. And I would put 0, whoops, I don't want to do that. I want to put my 0 here and a -5 here. And it says greater than. So if I'm using parentheses and brackets, you know, my rounded one and my square one, to graph this, I would make a square, a -5, and my arrow would go to the left, showing me that whatever y is, it's going to be bigger than -5, and it could even be -5. If I wanted to use interval notation, I would do this. And what would I use for my other number? Infinity. On the left-hand side would be infinity. Positive infinity is always going to be the right-hand number, if there is an infinity. Negative infinity will be on the left. So it kind of looks, it'll follow the line, you know, what's the word I want? What's this called? What's that line called? Number line, thank you. I don't know why my brain just went dead. Okay. It'll always follow the way a number line goes. You know, your left-hand number, right-hand number, you know, infinity there. Okay. Now what we have is we have what are called compound intersections, or inequalities, which is on page 410. And the definition is a compound inequality is two or more inequalities connected by the word and or the word or. So and in or. Okay? Those are two very important words here. One means intersection and one means union. And means intersection, or means union. Okay. So, let's look and see what happens here when we start messing with the ands and the ors. All right. We have, for example, x is less than -1, or x is greater than or equal to 3. All right, when you look at those two together, let me make this look a little better. Is it possible for us to say and? Is it possible for us to say x is less than -1 and x is greater than 3? X can't be both of those, right? It has to be one or the other. Okay. The and word just means that it works for both of them. This doesn't. There can't be a number that's negative and a number that's positive at the same time. So this is one of those or statements. The way you graph this, we get our, thank you Maddie, number line. And we have a -1 and we have a 1, 2, 3. So if you were to use number line format or a graph, you would circle at -1 into infinity, into negative infinity. You would square bracket at 3 and go positive infinity, right? They don't intersect. Because they don't intersect, they have to be an or, one or the other. All right, how would you write this in interval notation?
Just together or like, I don't know, separate? Or you just do one and then just start with one.
Okay. What you would do here is you would go negative infinity, -1, round, round. Okay? What would you do for this one?
Put a box and then infinity, but no negative.
Okay. That's what you would do with it. And obviously you're going to have two parts to it because there's no intersection. So you're going to have to write it twice because you can't write one symbol to make both of those true statements. You have to write them both as separate statements. Another way that they do, or one of the continuations for this, when you have the word or, what did I say was another word for the word or? Union. So what I would do is I would write negative infinity, -1, my bracket here with 3, my positive infinity, and I would make the union symbol. And that would be your answer for interval notation. Showing that the answers are two different directions on the graph and they union. It's one or the other, not a combination. Okay, so let's look what happens when we have not a union, but an intersection here. If I can get rid of all this. See, that time it all disappeared. So, example 4, if I have an and, I have x, and I'm going to use a different color, that's kind of hard to see. X is greater than -2, and, oh golly, x is less than 3. We still have a ways to go. So, can x be greater than -2 and less than 3 at the same time? Let's graph that and see what happens. So -3, +3. So if we were to graph x is greater than -2, what would that look like? Square or a parenthesis? Okay. Would it go this way or this way? The first way or the second way?
The second way, maybe?
Okay, the second way because it says greater. So it's going to be greater than -2, and it's going to go that way, right?
Yep.
Into infinity. The other one, we'll do this one in yellow, starts at is less than 3, so it's going to be open, and it's going to be this way into infinity. But because of this word and, we are locked into this right here. Because it says and, it has to work for both of them. Okay? I have a Snicker bar and a Kit Kat. It means you have both of them. It doesn't mean you have one or the other. So it has to include both of them, which means when you write this in interval notation, it's going to look like this. All numbers between -2 and +3. So sometimes it works. If they just say, write this in interval notations, most of my students will do this whole number line thing here first to find out what to do, and then write interval notation right here, because it's just a lot easier given the number line like that. Okay? Two more vocabulary words, and then we'll be done. One is called open interval, and one is called closed interval. Okay. Open interval means that neither endpoint is included in the answer, like this one here. X has to be greater than -2. It cannot be -2, and it has to be smaller than 3, so it does not include 3. So open interval means neither endpoint is included. Closed interval means both endpoints are included. So you know anything with infinity is going to have one of these symbols, right? So infinity will always be an open interval, because both sides have to be squared if it's going to be closed. Okay, so that gets us to page 411, example 4, and we'll continue on with the next couple pages then next time.